the musician maintains the stationary waves with the mouthpiece and antennode at the end. The lowest frequency of sound that the bugle can produce is 92 hertz. Okay, so this is basically the fundamental frequency that he's talking about. Okay, so we're going to write it like this: frequency, when the frequency is 92, it means Vn is 1 at fundamental frequency, it's going to 4L. That means 92 is equal to V upon 4L, right? Is it clear? No, Sohail, there is a problem going on. I don't know why. It was not being recorded, and I will now start recording separately. So then I'll upload it. No worries. Anyway. So what happens is that now you guys need to realize that the next frequency is going to be F equals to V times, it is 3, so we're going to write 3 over 4L. Because 4L, V upon 4L is 92, so I can write it as 92 times 3. 92 times 3 is 276, so these two are wrong. And then the next one will be V times 5 over 4L. V over 4L is 92, so 92 times 5 is 460, so C is the correct answer, D isn't. Is it clear, everyone? So it's as simple as this if you just look at this in this particular way. Get it? Okay, now in this one, some issue with the recording ones. Anyway, the tube of length L is open at both ends, so you have both ends open, so you should remember this. Now we know that what type of formula we're going to use. The stationary wave is set up in this tube when the tuning fork is vibrating at frequency fx. Is held at one end. This is the lowest frequency wave that can be formed in the tube. Okay, and the tube of 2L is closed at one end, and the stationary wave is set up when tuning fork vibrating with frequency fy. The lowest frequency of stationary form can be formed in this tube. Okay, so he's talking about the fundamental frequency on both ways. All right, like that. So what I'm going to do next is I'm going to say, it says which equation is correct. Now please understand this. So we got length here, we got two length here. First of all, for two ends open, we know the frequency formula is V times N over 2L, where N in two ends open is 1, 2, 3, 4, like that. Whereas in this one, frequency is V times N over 4L, where N is like 1, 3, 5, all odd numbers like this, okay? So fundamental means that the frequency here was fx when fundamental formed at 1 and it was 2L. So we get a formula that fx equals to V upon 2L. In the next one, the fundamental is formed when N was 1 here and then over 4L. So we know this is Fy, and Fy is going to be equal to Fy is equal to V upon 4L. Do you guys understand this at least? Now if I write this as, oh sorry, in this one the length was also 2L, sorry, my bad. So it's going to be 2 times 4, 8L like this. Anyway, so I can write it as 2Fx equals to V upon L, and I can write this as 8Fy equals to V upon L, because here we have V upon L, here we have V upon L, so we can write 8Fy equals to 2Fx, so 2 1 and 2 4, so Fx will be 4 times of Fy, which is D. Is it clear, everyone?
Yeah.
So unless you do not remember the formulas, you will be very, very upset with that. So please do remember that and make sure you learn all the formulas like this. Anyway, so I have basically put many type of questions here. You have to do this on your own now and try to make sure that if you do not understand them, let me know. I'll help you solve them in the next class. All of them I'm giving you as homework, but they're super easy as long as you just follow up with the formulas. It's very easy as well. Anyway, the next thing we're going to do is some essential experiments that there are in this chapter. For example, the water tube experiment. In the water tube experiment, we want to find the speed of sound. And how do we do this is that first of all, we got to adjust the length L1 till you hear a loud sound. When you hear the loud sound, it means that at this point an antinode has been formed because of the frequency of this tuning fork, right? So this is like the tuning fork. Then what you do is move the tube, it's up to you, up or down till you hear another loud sound and note length L2, like that. Then what you're going to do is you're going to subtract L2 minus L1, and this will give you the difference between two adjacent antinodes. Because when you moved it, like you moved it up, the new length, so there was an antinode formed initially and the new antinode would form. So it means the difference between L2 and L1 will give you this length, which is half lambda. So then use L2 minus L1 as half lambda, and then obviously you can simply find we can use then V is equal to F lambda to find speed of sound. Is it clear, everyone? Any questions here?
Clear, sir.
Okay, please write this down. Okay, then we can also do the same for through a reflection of wave experiment, where we form a wave like this. For example, you have a loudspeaker you're forming stationary wave from. So what you guys need to understand is that when the microphone is moved in a line, so when it reaches here, it would actually display the loudest sound or the highest amplitude on the CRO. And then as it's moving, when the microphone reaches here, it will display no wave. And then when it reaches here, it will again display another loud sound. So what we can do is we can find the difference between them. Alright, we can see that when two loud sounds are found, and then we can find this length. Okay, this length that we have moved would be the distance between two antinodes, and we can see it from the CRO directly. So this is pretty easy. So I'm going to say that as we move, the microphone along a line, CRO detects 0 amplitude at nodes, because we can't see this the wave itself. We can just detect where the loudest and the quietest sound is. All right. So zero amplitude at nodes and maximum amplitude at antinodes. All right. Then measure length L between two adjacent antinodes or nodes, and you know it from the CR, like you can know when two nodes have formed by looking at the screen from the CRO. So length L will be equal to half lambda, because it could be from node to node or antinode to antinode, whatever you're looking at. Then lambda will be equal to 2L, right, as we know. So use V is equal to F lambda to find speed of sound. Okay. So that's pretty simple. Now you can use the same experiment for microwaves as well. So, and you just need microwave detector, right, instead of a microphone, and you can find the speed of light as well if you want to. Any questions, please let me know. Right. Then you guys have written. Should I go forward now?
Yes, sir.
So again, the same question. This is what you're going to do, because this is like the same. And basically I'm interested in, like, you can do this one as well, but I'm actually interested in doing this question. So what it says is that the loudspeaker at B is held. Okay, so they say loudspeaker, whatever that was, at B it was held. And then they've shown you two levels where the water was, taken out. Now it says the tap at bottom is opened so that the liquid drains out at constant rate. The wavelength of the sound from the loudspeaker is this much. Okay, the sound that is heard first becomes much louder when the liquid surface reaches A, which means here an antinode will be formed. And the next time the sound becomes much louder is when liquid surfaces B. So it means the next antinode would be formed here. So between this level and this level, there are two different antinodes have formed. Alright, so you just need to remember that. Now it says calculate the vertical distance. So between antinode to antinode, this is like half lambda. So we can say that then half lambda will be equal to the length it has gone. The lambda is already given as 0.18. So the length will be equal to 0.09, and that should be our answer. Is that clear, everyone?
Yeah.
So it's pretty easy. And then it says that in the next one, you just need to label where the nodes are formed. So node will be formed here because this is the closed end, and node will be formed here. This will be a node as well. So and there will be next node will also be like, next node will be here as well, like that. So node and node wherever it is, fine. Then it says the mass of the liquid leaving. Okay, this is just the speed question, so you can do this on your own. This is simple. So then the reflection one comes. So again, principal superposition homework for you people, because that's you can write. It says what is the function of metal plate to reflect incoming progressive wave in the same line with same frequency and amplitude that forms stationary wave. Okay. Now it says calculate the frequency in gigahertz, okay, of the microwaves. Now what you want to do? It says the microwaves have the wavelength of this and stationary bomb in between wave and the plate. Fine. So you have the wavelength, you can use V is equal to F lambda. V will be 3.0 times 10 raised to power 8. Frequency we want to find. Lambda is 0.040. So we're gonna do 3.0 times 10 raised to power 8 and divided by 0.04. So we get like 7.5 times 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be 7.5 gigahertz, like that. Then it says the microwave receiver is initially placed at X, as you can see right here. And then it says that the receiver is then slowly moved away from X directly towards the plate. Determine the shortest distance from X of the receiver when it detects another intensity minimum. So obviously, if there was like node here, and the next time it would detect a node is when it will be equal to half lambda. Okay. Well, that's strange. Okay, so which means that now it's giving me so many problems today. What is this? Okay. So it says that now you need to determine the distance, because node to node is half lambda and the lambda was this. So we're going to say half of lambda, which is half of 0.040 will be 0.020, as simple as that. Determine the number of intensity maxima that are detected by the receiver as it moves from X, and that is 9.1 centimeter away. Now we need to understand this, that if the distance from this point to the reflecting plate is 9.1 centimeter, which is basically 0.091 meters, and this is the lambda. So every time a node will be formed, so there will be a node, and there will be at the end it will also be a node, like that. So let me just do it here like this. So at X it says determine the number of maxima that are detected by receiver as it moves X to Y. Fine. So minimum to minimum, node to node distance is this, and we have 9 points, so we're going to do it as this. And then if one node to node distance is 0.20, then how many node to nodes will be there in 0.091? We're going to cross multiply this, and we're going to say it's going to be 0.091 divided by 0.020. And if I do that, so it's basically telling me that it's going to be something like 4.5 nodes to nodes. There will be this many 4.5 nodes to node, which means they're going to be like one node here, then another node, and then another node. So we need to make 4 actually. Wait a second. node, then another node, so this is going to be half lambda, then another node, another half lambda, then another node, another half lambda, and another node, another half lambda, and 0.5 means they're going to be an anti-node because the next node will be half lambda. So it means that there will be an anti-node here, then another anti-node, another anti-node, another anti-node, another. So they're going to be 1, 2, 3, 4, and 5 number of anti-nodes because they're talking about the maximum. All right. Let me know if you understand this, please. Okay. All right. So the last thing we're gonna do. This is what you're gonna do yourself. Easy question. And also this one. This is also the same type of question that we've just done. The last experiment that we're gonna do before I move on would be the Kunstdust experiment. In Kunstdust experiment, basically a speaker is placed inside a tube where there's dust. So when the wave is created, the stationary waves, the dust begins to gather here. So it makes a heaps. Why it makes heaps is that because at these points there is nodes, and nodes cannot displace the dust because they have no energy. Anti-nodes can displace the dust because they have energy, right? So every time a heap forms, so between one heap to another heap, we can see that it is going to be half lambda. And then if the frequency of the speaker is f, so we can simply use the distance from a node to node or heap to heap to find the lambda. We can use the frequency of the generator, and then speed of sound can be found. So I'm going to write this down. I'm going to say that when signal generator forms a stationary wave, antinodes displaces the dust, and beneath the nodes it forms heaps of dust, right, like that. Then measure length L, let's write L, between two adjacent heaps, which basically represents nodes, okay, where then half lambda will be equal to that length and lambda will be equal to basically 12. Then use V is equal to F lambda to find speed of sound, just like this. All right. Let me know if you have a question now. Okay. So then just a second. Okay. So this would be the experiment. Finally, I just want to tell you that when you create stationary waves with respect to transfers, in transfers they just vibrate up and down like this, like that. So that's pretty simple. But in longitudinal, it's quite different. So you guys need to remember this. Like for example, you will always witness, particles going towards nodes like this, and as they're progressing, you guys should understand that they would sort of like they would grow smaller, like no displacement here, and they would grow larger and larger and larger, and then again they will become shorter and shorter like this, and then on the other side it will be the same, grow larger and larger and larger and shorter, so they will be one-sided, and then at nodes they will have no displacement. So just remember that nodes have no displacement, and the arrows are like sort of towards the nodes in that sense. Okay, so will you guys be able to remember that?
Yes.
Okay, we'll quickly draw this and then we'll move to the next part, which is one question, and then we're done. Unfortunately, the recording is gone, like it's been too bad today. The lecture was not recorded at all. So I'm going to post a different lecture from this, but the similar topic. Okay, so you guys can review that. Anyway, so for example, this question says there is a heaps of dust have formed, and says the speed of sound in air is this much, there's a frequency is this much, and what is the value of distance x. So we already know that these are nodes, which means that from here to here we have half lambda, from here to here we have half lambda, and from here to here we also have half lambda. So this means that basically all this distance that you see is like 1.5 lambda. 1.5 lambda is equal to x, right? So we can find the lambda using v is equal to f lambda. The speed was 336, the frequency was 1200, lambda was this. So we're going to use 336 divided by 1200, and that's going to be 0.28 meters. And because we want to find x was equal to 1.5 lambda, so we're going to write 1.5 times 0.28, and that's going to be 0.42 meters, which is 42 centimeters. Is it clear? Any questions?
Clear, sir.
Alright, so that would be all for today.